ladies and gentlemen. In this video, we're going to be talking about literal equations. What are they and how to solve them? Solving literal equations, well, actually, let's just start. What is a literal equation? A literal equation is just an equation that contains multiple variables, multiple, let's try that again, multiple variables, and usually represents a real world occurrence. So, for example, if you've been in science class, you might be familiar with distance equals rate times time, dirt. That is a literal equation. It's an equation made of multiple variables and represents a real world occurrence. I say usually because sometimes it doesn't, but for the most part, there it is. Let's see, can I think of another one? Here's one you might be familiar with. A squared plus b squared equals c squared. That's Pythagorean theorem. That is a literal equation. It's an equation that contains multiple variables and usually represents a real-world occurrence. This one represents the length of a diagonal side of a right triangle. These are these are really useful tools. We usually use them as formula for bigger problems. But sometimes we don't want to find distance. Sometimes we don't want to find c. Sometimes we actually want to find a. Sometimes we want to find r. Sometimes we want to find t. So we need to be able to rearrange these letters, but still get a useful equation. And that's what solving literal equations is all about. Solving literal equations is about changing the isolated variable. They are solved by isolating a specified variable. So, for example, for instance, example one, let's just do it. We have the area formula. Area equals length times width. I'm certain you've seen this one. Area equals length times width, right? But what if I didn't want area? What if I was really just curious? What would I do to find length? Well, we can solve by isolating the L, and that would be it. We would find out what length is. So let's do this. To isolate a variable, we've been doing this all semester so far. It's just undoing the unwanted term. And to undo an unwanted term, we just use the opposite operation, the opposite action. In this case, I want L alone, so I need to undo times W. So how do I undo times W? That's right, we divide. The opposite of times is division. So we would divide both sides by W. They would cancel out here on the right-hand side, and I would be left with A over W, area divided by width, is equal to length. Only this is kind of weird when you write it like this, so we're going to clean it up. We're going to put the isolated variable first. L, the length, is equal to area divided by, and that would solve literal equation. Does that make a little bit of sense there? All we're doing is undoing the unwanted variables, moving them over to the other side so that we can end up with a new isolated term. Let's try example. Example 2. Currently, Q is being isolated, but we want to isolate R. We want to get R alone. So that means we need to undo the T and we need to undo the S. So let's think, how would I undo plus T? Hopefully you've already guessed it. It's minus T. Very good. If I do it to one side, I have to do it to the other. These cancel out. And I'll be left with, well, I can't combine these, so I'll keep them separate. Q minus T equals R. And this is a pro tip, it'll really help. If you have two letters next to each other, put times sign. That'll really illustrate to you that is multiplication. Help you know the next step. Because the next step is to get rid of that S, right? So how would I do that? If it's times S, how do I undo times? Good. Divide by S. Okay? So we're going to divide by S. These guys cancel out. And I'm left with r is equal to, here it is, a really weird fraction, q minus t divided by s. All of it divided by s. Not just the q, not just the t, but both of them. All right, we got to clean it up too. This is isolated, so it's solved. Let's clean it up. Put the r first, we'll put q minus t, and then we'll put it over s. There you go. Another solved literal equation. Okay, last one. Here it is. Right now, the 10 is isolated, but I want to isolate the m. So that means I need to get rid of a lot of stuff. But I see some parentheses. So before I do anything, my first gut intuition is to simplify my problem. Let's distribute this 3. Distribute the 3 to the 2 and the 3 to the negative n. What do we get? We'll have 10 equals 3 times 2 is 6, so 6m. 3 times negative n is negative 3m. Okay. Now I want to isolate this m. That means I need to undo this minus 3n, and I need to undo that 6. So let's undo the minus 3n. How do I undo minus 3n? Good, we add 3n to both sides. Okay, those cancel out. I can't combine them, so I'll keep them separate. This will be 3n plus 10 equals 6n. And now I need to undo this 6. Remember, a coefficient in a variable is always multiplication. So to undo multiply, we divide. Divide by 6. And this is where something interesting is going to happen. I really need you to grasp. Notice how both of these terms have numbers. So instead of dividing the whole thing by 6, we're actually going to do them separately. And the reason for that is we need to, if I have numbers on the top and bottom of my fraction, there's a good chance that I can simplify them. So instead of doing it like this over here, where we did the whole thing over s, because there are numbers here, I want to see if I can simplify any of them. So we're going to keep them separate. All right, simplifying fractions, it's been a while. So let's see. How do you simplify a fraction? To simplify a fraction, you find a number that divides both the top and the bottom. Is there a number that divides 3 and divides 6? Yeah, 3. 3 divides 3, and 3 divides 6. So this one would end up being 1n over 2. 3 divided by 3 is 1, 6 divided by 3 is 2. How about this one? Is there a number that divides 10 and a number that divides 6? Yes, 2. 2 divides both of these. 10 divided by 2 is 5, and 6 divided by 2 is 3. Yeah? And then these 6's cancel out, so I'm left with just n equals 1n over 2 plus 5 over 3. But, like I said before, we want to clean this up. So I'm just going to rewrite it over here. M is equal to 1n over 2 is the same thing as just n over 2 plus 5 over 3. Odds are the first example made a lot of sense. The second example made a little less, but still, you feel pretty confident. It's going to be this third example really mess with your brain. So my advice, go back, rewatch it, especially right here. It's been a while since you've simplified. So one more time, we'll move the 3 over. And then, because there were numbers here, I divided both terms, not just all of it, both of them separately, so that I could try and simplify this. And I got my final answer. All right. Well, that's going to do it for this video. I'll see you in the next one.